Hello everyone. Let me continue that chemical kinetics part. So today I'll start the class with a question. Right now, consider a homogeneous gaseous equilibrium. Consider a homogeneous gaseous equilibrium. A gives rise to B plus C plus D. Okay. Just consider a homogeneous gaseous equilibrium like this. A gives rise to B plus C plus D. The initial pressure was P naught. The initial pressure was P naught and C. Just consider a homogeneous equilibrium. A gives rise to B plus C plus D. Gaseous homogeneous equilibrium. Okay. All of them are gases. Now let the initial pressure is P naught. Okay. While pressure after T time is P. Okay. Initial pressure is P naught while pressure after T time was P. If P greater than P naught, if P greater than P naught, the expression for rate constant K is the expression for rate constant K is, okay, the expression for rate constant K is, okay, so this is the question. Say for a homogeneous, consider a homogeneous equilibrium, A gives rise to B plus C plus D. The initial pressure was P naught while pressure after T time is P. If P greater than P naught, then an expression for the rate constant K is. Okay, here there is no data regarding order of the reaction, but A gives rise to B plus C plus D. So we are assuming it as a first order reaction. So just assume it as a first order reaction. So as per the options you can understand it. Okay. So here options were given, but I'll explain the question, right? So assume it as a first order reaction because one reactant gives rise to B, C and D. Okay. Now let me go through the explanation for this question of you. A gives rise to B plus C plus D. At T is equal to 0, the pressure is given as P naught. At T is equal to 0, the pressure is given as P naught. Okay. Now, initially there is no product, so तीनों का 0 होगा. At T is equal to T, let me make it as X. Then it is also becomes X, and this one becomes P naught minus X. Okay, P naught minus X. Now, after T time, total pressure is, P naught minus X plus X plus X plus X. Okay, that is always equal to P. Okay, now minus X plus X get cancelled. P naught plus 2X is equal to P. P naught plus 2X equal to P. Then 2X is equal to P minus P naught. Then X is equal to P minus P naught by 2. Okay. Then what is the expression for rate constant of first order reaction? What is the expression for rate constant of first order reaction? Okay, say for this step I think P naught plus 2X equal to P. So continuation यहाँ पे लिख रहा हूँ. First order rate expression क्या होगा? K equal to 2.303 by T log P naught by P naught minus X, no? And the X value is this much, substitute it, 2.303 by T log P naught by P naught minus P naught by T. Okay, by solving this, how much you are getting? So solve this expression, then the final answer will be log of 2P naught by 3P naught minus P. Right? Log of 2P naught by 3P naught minus P. So this is the final answer for this question. Is that clear? So it's an important point. I'll have you please listen carefully. Okay. Next, go through one more important question. I'll have you please check this question answer. Okay. Listen, another question. The rate constant for the production of 2B, the rate constant for the production of 2B gas by the reaction. Okay, the rate constant for the production of 2B gas by the reaction A gas gives rise to 2B gas is, A gives rise to 2B gas is 2.48 into 10 power minus 4 second inverse. 2.48 into 10 power minus 4 second inverse. A 1:1 molar, a 1:1 molar ratio of A to B in the reaction mixture is attained after a 1:1 molar ratio of A to B, 1:1 molar ratio of A to B in the reaction mixture is attained after. Okay, is attained after. So I'll give the options also here. So first option 26.25 minutes. 26.25 minutes is the first option. Second option 27.25 minutes. Okay. And the third option is given as 28.25 minutes. And the last one is none of these. Okay. See, values are somehow more closer to each other. That's why we have to go through very accurately do the question, right? So, let me go through the solution for this question. Now, A gives rise to 2B. Okay, A gives rise to 2B. A rate constant given second inverse. So from that you can understand it is a first order reaction. Because the rate constant has units of second inverse, that's why it is a first order reaction. Okay, initially assume 1 mole 0. मतलब है T equal to 0. Now at T equal to T, ये वाला 2x होगा, ये वाला 1 minus x होगा. तो क्या बोल रहे हैं इन्होंने 1:1 मोलर रेशियो ऑफ A to B is attained after some time. So वो T टाइम में, after T टाइम में दोनों इक्वल ले लो. मतलब 1 minus x is equal to 2x. Then 1 is equal to 3x. So x equal to how much you are getting? 1 by 3. X you are getting 1 by 3. Okay. Then k equal to 2.303 by t log A by A minus x, then t equal to 2.303 by 2.48 into 10 power 4 into log A इनिशियल कंसंट्रेशन। तो यहाँ पे इनिशियल कंसंट्रेशन 1 ले लो अब, तो बिकॉज वी हैव टेकन 1 ऑलरेडी। now x is given as 1/3, मतलब a minus x मतलब 1 minus 1/3, so that will be 2/3, then 2t is equal to 2.303 by 2.48 into 10 power minus 4 log 1 by 2/3, that equal to 2.303 by 2.48 into 10 power minus 4 log 3/2. Okay, so log 3/2 आ रहा है, तो यहाँ पे कर रहा हूँ। See, log 3 वैल्यू कितना 0.4771, log 2 वैल्यू कितना है 0.3010। ठीक, so टाइम पीरियड इक्वल टू 2.303 into 10 पावर 4 ऊपर लेके जाइए, 10 पावर प्लस 4 हो जाएगा by 2.48 log 3 minus log 2, how much? So it can be solved as 0.4771 minus 0.3010. Okay, 0.4771 minus 0.3010. By solving this, you will get 27.25 minutes. Okay, solve this, you will get this answer 27.25 minutes. So this is another important model in first standard kinetics. Right? Please note down. Okay. So let me go through a rate law expression for some special reactions. A rate law expression for some special reactions. Okay, listen carefully. Okay, kinetics of parallel path reactions. Okay, so next topic is kinetics of parallel path reactions. Parallel path reactions. Okay, so parallel path reactions मतलब reactant gives two products. One is major product, the other one is minor product. Okay, assume like this. Here A is reactant and it gives two products like this. One is B, the other one is C. Here it is K1, the rate constant. Here it is K2 is the rate constant. R1 is the rate of reaction in A2, A gives rise to B. R2 is the rate of reaction for A gives rise to C. And K1 greater than K2. Therefore, A to B is major reaction and A to C is considered to be minor reaction. So, like this, same reactant gives two different products simultaneously, then it is called as parallel reaction. Same reactant gives two different products. One is major product, the other one is minor product. Here A gives rise to B where rate constant is K1, A gives rise to C where rate constant K2. K1 greater than K2, that's why A to B is major reaction and A to C is considered to be minor reaction. Okay, let the concentration of A after T time, let the concentration of A after T time is taken as AT. Okay, you just assume the concentration of A after T time like this, A at T time. Okay, therefore R1 is equal to क्या होगा K1 into concentration of A at T time. मतलब rate is directly proportional to concentration of reactant at that instant of time. And similarly R2 is equal to क्या आएगा K2 into concentration of A at that instant of time. So R1 major reaction के लिए R1 equal to K1 into concentration of A at that instant of time. For minor reaction R2 is equal to K2 into concentration of A at that instant of time. Therefore, overall rate with respect to A. Okay. Therefore, overall rate with respect to A. Overall rate at which A reacts or with respect to reaction of A. कैसे लिख सकता है? R equal to minus D concentration of A by dt. R is equal to minus D concentration of A by dt. That is equal to R1 plus R2. Because these two are parallel reactions, so sum of the rates of these two is equal to overall rate. Overall rate equal to sum of the rates of major and minor reaction. So R is equal to R1 plus R2. So that is equal to then it can be written like this: minus D concentration of A by dt minus D concentration of A by dt is equal to क्या? K into concentration of A at the t time. Okay. Or you can write this expression like this also. You can write this expression like this. कैसे? Minus D concentration of A by dt is equal to R1 plus R2. So K1 into concentration of A at t time plus K2 into concentration of A at t time. Therefore K1 plus K2 can be written as K. Therefore K1 plus K2 is written as K. Okay. And again, K can be written as being a first order reaction 2.303 by T. K equal to 2.303 by T log concentration of A initially by concentration of A after T time. Okay. So here here K is a overall rate constant of this first order reaction. Okay. Next, one more important point you have to remember here is so continuation for this. R1 by R2 is always equal to K1 by K2 क्योंकि concentration term get cancelled ना. R1 by R2 is equal to K1 by K2 where concentration at that instant of time get cancelled. And one more important aspect, D concentration of B by dt will be equal to D concentration of B by dt will be equal to B at t time is equal to K1 into concentration of A at t time. Like that with respect to C also you can write D concentration of T by C at t time by dt is equal to K2 into concentration of A at t time. Okay. So from this you can find the concentration of B and C also. Okay. So the ratio of these two can be written like this: B concentration of B after t time by concentration of C after t time is equal to K1 by K2. Okay. So therefore final expression K1 is equal to K into fractional yield of B. K overall rate constant into fractional yield of B. And K2 is equal to K into fractional yield of C. Fractional yield of C. Okay. So that's it. It's about a rate law expression for parallel reactions. Okay. So that too, you should assume that both are following first order kinetics. Reaction से पता चल जाएगा ना. A gives rise to B and C. Both major and minor reaction both follows first order kinetics. That is the must and should condition. Both major and minor reactions follows first order kinetics. Then only we can be able to derive like this. Okay. So that's it. Next, coming to another topic. Listen carefully. Okay, now going to kinetics of parallel reactions. Parallel completed. reversible reactions. Now I am going through kinetics of reversible reactions. Okay. Kinetics of reversible reactions. Now listen. Assume a reversible reaction. See, assume a reversible reaction. A gives rise to B. Okay. We just assume a reversible reaction like this. A gives rise to B. Okay. Now, the rate constant of forward reaction is Kf and the rate constant of backward reaction is Kb. Now, both forward and backward reactions follows first order kinetics. Okay, we are assuming that both forward and backward reactions follows first order kinetics. Okay. Then, so go through this. A gives rise to B. Kf is rate constant of forward and Kb is the rate constant of backward. At t is equal to 0, matlab initially, concentration of reactant is taken as A0. At t equal to 0, initially concentration of A is taken as A0. After t time, at t equal to t time, so let the concentration of B is taken as X, initially 0, after some time it is X. Then concentration of A left is initial concentration minus X. Initial concentration minus X. Okay. Next. Now, overall rate of reaction. See, overall rate of reaction can be written as what? Sum of the. See, if it is parallel, you can take the sum of the reactions. If it is parallel, like major minor. But here one opposes the other, so you should take the difference. So overall rate of reaction is equal to क्या लिख सकते हैं आप? Rate of forward reaction minus rate of backward reaction. So overall rate of reaction can be taken as the difference between the rate of forward reaction and rate of backward reaction. Okay, so कैसे लिख सकता है? Minus d concentration of A by dt. Say rate with respect to A. मतलब in forward direction we can write it as minus d concentration of A by dt. Okay, minus d concentration of A by dt minus D concentration of B by dt. समझ रहे हैं ना? Forward rate minus backward rate. That will be equal to क्या? dx by dt. Okay. So overall rate dx by dt is equal to rate of forward reaction minus rate of backward reaction. So it can be written as Kf into concentration of A at that instant of time minus Kb into concentration of B at that instant of time. Okay, A at that instant of time, B at that instant of time. So if you take after t time, what you written? X and A0 minus X. Therefore, overall rate can be written as dx by dt is equal to Kf into concentration of A0 minus X minus Kb into X. क्योंकि B at that instant of time, concentration of B taken as X. Okay. Now, very important point. At equilibrium, अगर if you want to find equilibrium, at equilibrium क्या होगा? dx by dt is 0. क्यों? Rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. So dx by dt equal to 0. And x can be replaced with xeq, मतलब equilibrium concentration. X can be replaced with xeq, that is equilibrium concentration. Therefore, what I can write? Kf into concentration of A naught minus XEQ is equal to Kb into concentration of X at equilibrium position. So this is the final expression. Okay. So up to this much is enough. No need to go through. और if you want to find equilibrium concentration XEQ चाहिए तो इसको solve करके फिर आगे बढ़ सकता है. But we require only this much. As per our NEET syllabus and JEE, you better to go to up to this much. Overall rate of reaction in case of reversible, rate of forward reaction minus rate of backward reaction. Is that clear? Okay. Right. Okay, so let me go through a question based on this. Okay, if you go through this question, N2O4 gas gives rise to 2NO2 gas. Forward rate constant K1, backward rate constant K2. Then find the rate of disappearance of NO2. This is the question. So he is asking for NO2. So write the equation like this. So now I am asking 2NO2 gives rise to N2O4 gas. So K2, K1. Okay? Right. Now, half into D concentration of NO2 by dt. Matlab, I am taking, see the question is given like this, but he is asking rate of disappearance of NO2. That's why I just made an equation in reverse way. So now minus half into D concentration of NO2 by dt is equal to क्या लिखना है यहाँ K2 into concentration of NO2 power 2 minus K1 into concentration of N2O4. But he is asking rate of disappearance of NO2. What he is asking? Minus D concentration of NO2 by dt. Then this half comes this side. That equal to 2 into K2 into NO2 power 2 minus 2K1 into concentration of N2O4. Understand? See, half D concentration of O2 by D2. Now he is asking only disappearance of NO2. This half will come this side. So this whole part is multiplied by 2. I just multiplied with 2 and I written the answer. So like that you have to understand this question. Right? Understand all of you? Okay. Okay, go through another question. A gives rise to B and C. A gives rise to B and C. Rate constants are given as K1 is equal to 2 into 10 power 3 second inverse. K2 is equal to 6 into 10 power 3 second inverse. Okay? 2 into 10 power 3 second inverse and 6 into 10 power 3 second inverse. दोनों first order, right? A gives rise to B, A gives rise to C. Now, find the fractional yield of B and C. Find the fractional yield of B and C. Okay. Now, याद रखिए K2 greater than K1. Therefore, A gives rise to C. Major product, major reaction. A gives rise to B is considered to be minor reaction. Okay. So first fractional yield of B. Fractional yield of B. मतलब K1 is equal to K into concentration of B. Okay. Or better to say into fractional yield of B. So therefore fractional yield of B is equal to क्या लिखते हैं K1 by K. अगर परसेंटेज चाहिए तो so concentration or B percent or fractional yield of B in percentage. Fractional yield of B in percentage is equal to K1 by K into 100. So what is K? K कैसे कैलकुलेट करेंगे? K is equal to K1 plus K2. So 2 into 10 power 3 plus 6 into 10 power 3. So that will be 8 into 10 power 3 will be the K1. So percentage of B is equal to K1 2 into 10 power 3 by 8 into 10 power 3 into 100. 10 power 3, 10 power 3 get cancelled. So 100 by 4, that is 25%. Similarly, percentage of C कितना होगा? K2 by K into 100. So that will be equal to 6 into 10 power 3 into 100 by 8 into 10 power 3 into 100. Okay. So 10 power 3, 10 power 3 get cancelled. Sorry, नीचे 100 कैसे? So 8 10 power 3, 10 power 3 get cancelled. So कितना है? 600 by 8. So that's about 75%. Okay. So fractional yield of B is 25% and C major product लेना, it will be 75%. So this is the kinetics of parallel path reaction. उसका basis एक क्वेश्चन दिया. Okay. So major part of the kinetics I just completed and a few questions I have given. So I think if you feel this information is valuable for your NEET and JEE, please like this video, subscribe it and share it kindly. Thank you all.